From World War II piston fighters to today's stealth machines, Lockheed and the company that later became Lockheed Martin have produced the most influential combat aircraft ever built. So, today we're breaking down every major Lockheed and General Dynamics fighter, from the oldest legacy models to the newest cutting-edge tech, explaining what it was designed to do and what each one cost to build. So starting in 1941, during World War II being Lockheed's first fighter, is the P-38 Lightning. Coming in at $97,000 per aircraft, the P-38 Lightning was a completely different-looking fighter compared to everything else in the sky. Instead of a single main-body aircraft, it used a twin-boom layout, where two long structures extend back from the wings to hold the tail, with the cockpit sitting in the center pod. That unusual design solved multiple problems at once. The twin engines increased its speed and range, while the central nose allowed Lockheed to mount all the guns directly forward without wing convergence issues. This setup helped the P-38 reach speeds of around 414 miles per hour, making it one of the fastest fighters of World War II. The P-38 carried 4 machine guns and a cannon in the nose, meaning its firepower stayed concentrated at any distance. That made it extremely effective in both dogfights and ground attack. It also had exceptional range for the time, which made it perfect for long escort missions in the Pacific Theater. In fact, the P-38 is famous for carrying out one of the most precise air operations of the war, the mission that shot down Admiral Yamamoto, the Japanese commander who planned the attack on Pearl Harbor in 1943. By the end of the war, the Lightning had proven Lockheed could build world-class fighters, but the entire aviation industry was about to change forever because the next aircraft in the timeline would ditch propellers entirely. Coming up next, in 1945, the P-80 Shooting Star, costing $55,000 per aircraft. The P-80 Shooting Star became America's first operational jet fighter. Everything about it was a step into the future. The P-80 used a turbojet engine which allowed it to fly much faster than piston fighters. A turbojet pushes air straight through the engine and blasting it out the back to create thrust, rather than spinning a propeller with a piston engine. Early versions pushed speeds over 550 miles per hour, which was a huge jump compared to World War II aircraft. It established the blueprint for early jet fighters with straight wings, a single engine, and a nose intake feeding air directly to the turbojet. Although it arrived too late to see combat in World War II, the P-80 became heavily used during the Korean War and helped bridge the transition between propeller aircraft and the supersonic jet age that was just around the corner. Moving forward to 1949, about a third of the way into this list, is the F-94 Starfire. With a cost of around $1 million per aircraft in early Cold War dollars, the F-94 Starfire was designed to defend the United States from potential Soviet bomber attacks. It could reach speeds of roughly 640 miles per hour, making it significantly faster than many early jet fighters that came before it. Unlike earlier fighters, the Starfire was built as an all-weather interceptor, meaning it carried radar and could track enemy aircraft even at night or through clouds, instead of relying purely on pilot eyesight. The radar operator in the second seat could guide the aircraft toward incoming targets. This was a huge leap in capability for air defense missions. The F-94 introduced rocket armament rather than traditional guns in some versions, allowing it to unleash massive bursts of firepower against bomber formations. Rocket armament means the aircraft fired unguided rockets instead of bullets, which explode and spread damage over a wider area. The Starfire marked the beginning of a new era where electronics, sensors, and interception capability mattered just as much as raw speed. Coming up next, in 1949, is the XF-90, costing roughly $2 million per prototype. The XF-90 was an experimental long-range jet fighter designed for escort missions. It had swept wings, twin-jet engines, and a much heavier structure compared to earlier fighters. The aircraft was designed to travel extremely long distances while still maintaining fighter performance. The problem was weight. The XF-90 ended up being too heavy and underpowered compared to competing designs. Only 2 prototypes were built, and the aircraft never entered production. But the lessons learned from the XF-90 helped Lockheed engineers understand how to design high-speed jet fighters for the next generation. Jumping halfway into the list in 1954 is the F-104 Starfighter. With an approximate cost around $1.4 million per aircraft in early production, the F-104 Starfighter was designed around the philosophy of pure speed. Lockheed engineer Kelly Johnson created a fighter with incredibly tiny wings and a powerful engine, allowing it to reach speeds of roughly 1,300 miles per hour, which is over twice the speed of sound. The wings were so thin and sharp that ground crews had to put protective covers on the edges so people wouldn't get cut walking near them. The result was an aircraft that could climb extremely fast and intercept enemy bombers at high altitude. However, the Starfighter demanded a lot from its pilots. Its high landing speeds and demanding flight characteristics made it a difficult aircraft to fly. Despite that reputation, the F-104 became widely exported and served with many NATO air forces during the Cold War. Moving to 1963 is the YF-12. Costing an estimated $18 million per aircraft, the YF-12 was essentially a fighter version of the famous SR-71 Blackbird. The SR-71 Blackbird itself was a long-range reconnaissance aircraft built to fly extremely fast and high over enemy territory to photograph military sites while being nearly impossible to intercept. This aircraft was designed to intercept enemy bombers at extreme altitude and speed, flying above 80,000 feet and exceeding around 2,200 miles per hour, which is over Mach 3. At those speeds, traditional dogfighting was irrelevant. The idea was to detect enemy aircraft from extremely far away and destroy them with long-range missiles before they ever approached U.S. airspace. Although the YF-12 program was eventually canceled, it demonstrated that interceptor aircraft could operate at speeds and altitudes that were previously unimaginable. Moving ahead to 1974 is the F-16 Fighting Falcon. Costing roughly $14 million per aircraft during early production, the F-16 was designed as a lightweight, highly maneuverable fighter. Instead of focusing on extreme speed like the F-104, engineers focused on agility and pilot control. The F-16 can reach speeds of around 1,500 miles per hour, giving it both strong agility and serious top-end performance. The aircraft introduced fly-by-wire flight controls, where the pilot's controls are sent electronically to onboard computers that move the aircraft's wings and tail surfaces to control the plane, rather than using direct mechanical linkages. This allowed computers to assist with stability and maneuvering. This made the aircraft extremely responsive in dogfights. The bubble canopy provided excellent visibility for pilots, and the side-mounted control stick improved ergonomics during high-G maneuvers. The F-16 quickly proved itself as one of the most versatile fighters ever built. It could perform air-to-air combat, ground attack, and reconnaissance missions with equal effectiveness. Decades later, it remains one of the most widely used fighters in the world. Now, 70% of the way into this list, in 1981, is the F-117 Nighthawk. Costing roughly $42 million per aircraft, the F-117 was not a fighter at all. It was a stealth attack aircraft designed for precision bombing missions. It appears in this lineup because it fundamentally changed how air combat works. The F-117 was the world's first operational stealth aircraft. Its angular, flat-panel surfaces were designed to scatter radar waves in many directions, making it extremely difficult for enemy radar systems to detect. And although it could only reach speeds of around 680 miles per hour, its real advantage was its ability to slip through enemy defenses without being seen. During the Gulf War in 1991, F-117s struck heavily defended targets in Baghdad while flying through dense air defense networks. The success of the F-117 proved that stealth technology could redefine air warfare. Coming up next, in 1997, is the F-22 Raptor. With an estimated cost of around $150 million per aircraft, the F-22 became the world's first fifth-generation fighter. It combines stealth, high speed, advanced sensors, and incredible maneuverability into one aircraft. Unlike previous fighters, the F-22 can cruise at around 1,200 miles per hour, which is supersonic speed without using afterburners, a capability known as supercruise. With afterburners engaged, it can reach speeds of roughly 1,700 miles per hour. Its stealth design allows it to detect enemies long before being detected itself. In real-world exercises and simulations, the F-22 has consistently dominated opposing aircraft with overwhelming kill ratios, proving it can control the sky before enemies even realize it's there. Even decades after its introduction, the F-22 remains the most capable air superiority fighter ever built. Last but not least, moving ahead to 2006, is the legendary F-35 Lightning II. With a production cost roughly between $80 to $110 million, depending on the variant, the F-35 is the most advanced multi-role fighter currently in production. It combines stealth technology, advanced sensors, and networked battlefield awareness. The aircraft can reach speeds of around 1,200 miles per hour, giving it strong performance while still prioritizing stealth and sensor capability. Unlike previous fighters, the F-35 acts as a flying data hub, sharing information with other aircraft, ships, and ground forces, essentially creating a battlefield hive mind where one F-35 can detect a target and instantly pass that information to other jets or missiles miles away to engage it. 3 variants exist, including the F-35A, which is the standard conventional takeoff version used for traditional runway operations and general multi-role missions. The F-35B is the short takeoff and vertical landing version that can operate from small runways and amphibious assault ships by hovering and landing vertically. The F-35C is the carrier version designed for aircraft carriers with larger wings for better low-speed control and stronger landing gear to handle the violent catapult launches and arrested landings at sea. The goal of the F-35 program was to replace dozens of older aircraft with a single, flexible platform, and today it has become the backbone of modern Western air power. Looking back across this timeline, you can see how fighter jet aircraft evolved from piston engine machines like the P-38 to stealth aircraft like the F-35. Speed dominated early Cold War designs, maneuverability defined fighters like the F-16, and stealth reshaped modern air combat. Lockheed, General Dynamics, and eventually Lockheed Martin played a major role in nearly every step of that evolution. Thanks for watching, and comment below which Lockheed fighter you think is the most impressive and what aircraft manufacturer you want to see next.